Good morning. In today's session, we have to study about the speed control method of the DC shunt motor. We will wait for other students for 1 minute, then we will start our today's session. At that, we can review our previous session. In previous session, we have studied about the DC machines. DC machines we are calling as a electromechanical energy converter because these are using EMF or these are generating EMF. It means what? If we are having the DC motor at that time, it is using the electrical energy and it will give us the mechanical. And if there is a DC generator at that time, it will use the mechanical energy and it will give us the electrical energy. Then we have seen the constructions of the DC machines. DC machine means what? DC motor and DC generator. If you see, construction is exactly same for both. Only what is the difference? In DC motor, there is back EMF generated, and EMF that is generated in the DC generator we are calling as a generated EMF. Sanket, please mute yourself. Okay. Then we have studied stator and the rotor. Stator means what? If you see the construction diagram for the DC machine, at that time you will get pole and yoke, outer current, outer covering of the DC assembly, DC motor. We are calling that as a yoke and the poles are the stator of the DC motor, and armature, commutator. Then if you see the brushes, all these are the rotationary part of the DC motor. Then we have studied how to calculate the EMF, generated EMF and the back EMF, the significance of the back EMF in the DC motor. Then we have studied about the torque equations. Then we have seen there are the different types of the DC motor, DC machines, depending on how we are giving the power supply. It means what? If we are not giving power supply separately to the field winding and the DC motor, we are giving power supply to the DC motor and it will generate the power supply and it will give that power supply to the field winding. Depending on this concept, there is self-excited and separately excited the DC motor. We have seen this concept. Then we have seen there are different loads we can connect at the output of the DC motor, and when we rotate the DC motor at that time, some part or whole assembly of that load will also rotate, and depending on this we have seen already the dynamics of load at the DC motor. In today's session, we have to study about the speed control methods of the DC shunt motor. Siddesh. Okay. So in yesterday's session, we have studied about the DC shunt motor. We are calling DC motor as DC shunt motor when the field winding is in shunt or is in parallel with the armature winding. We are calling that as the DC shunt motor. I will show you the diagram. If you see here, field winding is in parallel with the armature. That's why we are calling it is as the shunt motor. Then we have seen how to draw the characteristics graph for the DC shunt motor. For that, we will be needed the value of armature current. We will be needed the speed of that DC motor. We will be needed the torque equations for the DC motor. For that, we are supposed to derive the equations for the value of armature current by using the KVL to this loop. Then we are supposed to use the back EMF equations to derive the equations for the torque. And when we will get the equations for torque and armature current, at that time we have seen the value of armature current is in directly proportional with the armature torque is directly proportional to the armature current. That's why we will get it's a linear graph. Then we have studied about the speed versus current. If you see here, the speed will almost remains constant. It is only the minor change with respect to the value of current. That's why we are using DC shunt motor in various applications, because it is giving us the constant amount of speed. Then we have studied about the graph of speed versus torque. Here we can see the value of speed is negatively proportional with the torque. That's why it is also decreases with small amount with increase in a torque. In today's session, we have to study about the speed control method of the DC shunt motor. So already we have seen about the back EMF. If we are calculating the back EMF for the DC motor, it is nothing but it is the induced EMF, but it will be in the opposite direction with the supplied voltage. So we are calling that induced EMF just because of the rotation of the armature in the magnetic field, and we will get the equations for the magnitude of back EMF as NP5 into Z upon 60A, and we are calling this EMF as, we can use here unit as a volt. If we are giving KVL, we are applying KVL to the DC shunt motor, we will get the equations EB equal to V minus IA RA, because if you see in DC motor, we will get total voltage that will be equal to EB plus IA RA. So we can rearrange that equation and you can write EB equal to V minus IA RA. So here, when you are writing EB equal to minus IA RA, if you are putting that value of equation 1 in the second equation, you will get equations in the form of NP5, because you will be needed here equations for the speed. And if you see what मैंने क्या किया है, सिर्फ ये जो यहाँ पे मेरा EB का वैल्यू है वो मैंने इसमें पुट किया है. And when you will rearrange that equations, so from your first equations you are getting here. What you are getting here, if you are rearranging this equation, you will get N equal to EP into 60 into A upon P5 Z. So here, if you see 60 is constant term, A and Z are nothing but related with the cross-sectional area. And as the construction of DC motor will be constant, this cross-sectional area will remains constant. So यहाँ Z और A क्या रहेगा? Constant रहेगा. And if you are taking the number of pole in the DC shunt motor as a constant, so here what you will get? You will get directly, your speed is directly proportional with the back EMF and it is inversely proportional with the phi. So here we can say about the speed of DC motor, like it will be directly proportional with the back EMF and it will be inversely proportional with the magnetic flux per pole. So now I have written the same equation, the fourth equations which we have got. From second equations, we are having EB equal to V minus IA RA. But we will be needed here the speed control method, because we are supposed to control the speed of DC motor. How we can control? We are supposed to control the speed by controlling armature current, armature resistance, or the generated flux. That's why I am putting the value of EB equal to V minus IA from equation 2 in the equation 4. So our equation 4 will become, N will be directly proportional to the V minus IA RA upon 5. स्क्रीन दिख रहा है, आवाज आ रही है ना सभी को?
Yes, ma'am.
Okay. So here, if you see what we are saying, here we are saying speed is depending on the value of armature current. This is the power supply. It will be depend on us how we are giving the power supply. But when we are giving the power supply, that will remain the constant. So in practice, if you see, the value of speed will be depend on the armature current, armature resistance, and the fluxes. Depending on, there are three general methods to control the speed of DC shunt motor, and these methods are variations of field flux. It means what? We can variate generated flux and we can control the speed. If we are having the magnetic flux higher, speed will decrease, because you can see speed is inversely proportional with the flux. So we can call this method as a field flux control. Again, if you see here, N is directly proportional with negative IARE. It means what? Again, we can control speed by controlling the resistance variation in the armature. So we can call this method as a armature resistance control, or we can call rheostat control. Rheostat means what? Variable resistor होता है. So we can control the value of resistance by using the rheostat. So we will get to control the speed of DC shunt motor. Otherwise, again, we can control our giving voltage. So variation of applied voltage. You can see here, speed is directly proportional with the supply voltage. We can call this method as a armature voltage control method. So this classification of speed control method for DC shunt motor are as follows. We can control here the field control parameters, or we can control the armature parameters, because in field winding we will get the field fluxes, and if you see armature, on the armature current and on the armature resistance, the value of speed will depend. So depending on these two concepts, we will get. Piyush, please mute yourself. Here you can see here, depending on how speed is controlled on field parameters, or it is controlled on the armature parameter. There are different two control methods for the DC shunt motor. If we are controlling the parameters of armature, we can call armature control DC shunt motor. And we know if we are supposed to control the speed, we can control armature resistance or armature voltage. So these are the two types in the armature control DC shunt motor. If we are supposed to control the speed by using the field parameter, we can control the speed by controlling the field flux. So we can variate the field flux, and we can control the speed. We are calling this method as a field control DC shunt motor. Now we are supposed to study in today's session about how we are controlling the DC shunt motor speed. So here you can see, here we are using resistor और उसके साथ एक arrow होता है. We are calling this as a rheostat. We are calling this, if we are writing only zigzag sign, we are calling this as a resistor. But if there is a resistor and we are using here one incoming directions arrow, we are calling this as a rheostat. This is the type of resistor, but it is the variable resistor. It means what? We can control that value of resistor. So here, to control the speed of DC shunt motor, we are using here rheostat. So it is the type of DC shunt motor speed control method for the DC shunt motor by using the armature parameter. And what we are doing here, we are controlling here the resistance of armature. So we can say here resistance variation in the armature circuit we can control to control the speed of DC motor. So in this method we are using RE as armature rheostat resistance, and this figure will show about how we are connecting the DC shunt motor. If you see here, we are calling this as a shunt motor because this is the field winding, it is in parallel with the DC motor, and we are connecting that resistance that will be in series with the DC motor. The same diagram जो हम क्या करते थे, DC मोटर लेते थे और उसके पैरेलल में यहाँ पे हम डीसी मोटर लेते थे और उसके पैरेलल में फील्ड वाइंडिंग, एंड हियर वी आर गिविंग द पावर सप्लाई. व्हाट इज द डिफरेंस? हियर ओनली वी आर टेकिंग वन एडिशनल रिवोस्टेट. द रेजिस्टेंस वहां पे भी था. वी आर कॉलिंग आर ए एज इट इज. वी आर कॉलिंग फील्ड रेजिस्टेंस एज आरएसएच, और यू कैन कॉल एज अ आईएफ, द करंट फ्लोइंग थ्रू दिस shunt resistance, or you can call this resistance as RF. This is the field resistance, and we are calling this as a rheostat because we can control the value of speed by controlling this resistance. because we are having the formula N equal to V minus IA RA upon flux. So we can control the speed by controlling the value of resistance. There will be question like you are supposed to explain about the speed control methods using armature parameters in the DC shunt motor. At that time, you are supposed to explain about the armature resistance and you are supposed to explain about the power supply, which we are giving to the DC motor. Now we can see the equations. When we are giving here rheostat, this is our simple DC shunt motor. We are giving here voltage at that time, total current will be divided to the DC motor and the field winding. What will be the difference here? Here only one additional resistance will come. So what will be the difference in equation? EB will remains as it is because DC motor तो same यहाँ जो use किए वही use कर रहे हैं. अब किसी का क्वेश्चन रहेगा मैम you have used here a letter A, you are using here M, both are having the same meaning. Here I am armature A for and this is M for motor, both are motor and armature having the same meaning. DC motor is nothing but the armature and field winding that will be in parallel with respect to the armature. That time we are calling this as a decision because here if you see we are giving power supply to the motor and it will give power supply to the field winding. That's why we are calling it is as a decision. So here when we will apply KVL, you will get equations for that voltage flowing across the DC motor will be EB that will be generated back EMF plus IA and total resistance. Total resistance will be RA plus RE. So you can rearrange that equation in the form of EB, you will get these equations. When you are writing these things in exam, at that time, there is no need to write this. I am writing here these things, decision motor, only to understand how we are taking the equations. Because mechanical में तुम लोगों को इलेक्ट्रिकल के कंसेप्ट इतने अच्छे से नहीं पता है, इसलिए मैंने ये यहाँ पे फिर से ड्रॉ किया है. बट व्हेन यू आर supposed to derive the speed control method for decision meter, you can directly draw this and you can directly write these equations. Okay, so here we can say when large amount of power is wasted in the external resistors, because if you see we are having here two resistors, one additional resistance because we are using here rheostat. But we know when we are having DC shunt motor, at that time our equation is N will be directly proportional to V minus IARA and it will be inversely proportional to the phi. Here when we are supposed to study about the DC shunt motor using rheostat, at that time here value of flux also change due to change in the armature current, but that change will be less compared to change in EB. So you can directly take N is directly proportional to EB and again you can write N is directly proportional to V minus IA RE. There is no need to write for RE because if you see as EB value reduces to addition of RE, speed will decreases and you will require higher speed. That's why this is the drawback of the speed control method by using the rheostat, because here we are having one additional resistance. That's why just because of addition of RE, the value of EB will decrease. And as value of EB will decrease, our speed is directly proportional to the EMF. तो EB का value decrease हो रहा है तो speed भी क्या हो जाएगा? Decrease हो जाएगा. लक्ष्मण, please mute yourself. क्लास ज्वाइन होने के बाद ही मतलब अभी क्लास खत्म होने आ रहा है और तुम अब ज्वाइन कर रहे हो. You have already missed your half hour. Okay. You can see here what we are saying here. When we are controlling the speed by controlling the value of rheostat, it means what? By controlling the value of resistance across armature. At that time, if we are using one additional resistance, what we will get here? We are getting the equations as EB equal to V minus IA into RA plus RE. So here we are getting one additional resistance. So we are taking one additional resistance, so there will be larger amount of power will get less lost. So what will happen here? If the value of resistance will increases, you can see here how our equation is directly proportional. EB is directly proportional to the RA. How? With negative sign. So if resistance will increase, EMF will decrease. So as value of EB will reduces due to increase in value of resistance, speed will decrease, because you can see here speed is directly proportional to the EMF. और जैसे EMF का वैल्यू रिड्यूस हो रहा है, EB का स्पीड तुम्हारा डिक्रीज हो जाएगा. सो दिस इज द ड्रॉबैक फॉर द रेजिस्टेंस वेरिएशन इन द आर्मेचर सर्किट. A larger amount of power is wasted in the circuit because of the external resistance. So armature resistance control is restricted to keep the speed below over the normal speed. That's why we cannot increase here speed over the normal speed, and this is the drawback of the resistance variation in the armature circuit. So here we can see another variation of flux. So if we are supposed to derive the relations how we can control the speed of DC shunt motor by controlling the flux. What is the difference here in the circuit diagram? You can see here DC motor as it is. We are taking here DC motor, we are taking here armature resistance. And what we are supposed to do here, we are supposed to control the field flux. That's why we can see here we are using the rheostat, but in series with the field winding. So here, since the field current produces the flux, because we know flux where will be generated, जहां पे फील्ड रहेगा वहीं पे फ्लक्स जनरेट होगा, बिकॉज जहां पे फील्ड है वहीं पे इंडक्टर है. एंड व्हेन वी विल गेट द इंडक्टर एट दैट टाइम, we will get when we will give the power supply at that time, here we are using that field winding and it will be cut by the conductor, so we will get generated flux. So here we will get the generated flux in the field winding, so we can control the field current and we will be get to control how speed of the DC shunt motor, because this is the concept for the field winding. Because here we are supposed to control the flux which are generated by the field winding. That's why we are giving here rheostat in series with the field winding. So here we are calling that resistance as a shunt field regulator. We are calling regulator because it is a variable. We can control its value. So to control the flux, this is also one type of rheostat. So to control the flux, the rheostat is added in series with flux field winding, and that will increase the speed, because we know how it will be related with the flux. You can see here, speed is inversely proportional to the flux, and as we are using here rheostat in series with field winding, you will get increase in flux, because you will get increase in speed, because we are decreasing here flux amount, and we have seen speed is inversely proportional to the flux. So as we are using rheostat that will be in series with field winding, we will get increase in speed because of flux will decrease. So the field current is relatively small and loss will also decrease here. So this is the advantages of variation of field flux over variation of armature resistance. Because if you have seen there is a lots of power will get lost, because we were using additional resistance with the DC motor, but here we are using resistor with the field winding. That's why generated flux will get reduced, and as flux will get reduced, we will get the higher amount of speed. So now we can see the advantages. This method is very easy, it is convenient, and as the shunt field is very small, the power loss will be also very small. The flux cannot usually increase because we are decreasing here flux because we are supposed to increase the speed, and here the flux cannot usually increase beyond its normal value because of the saturation of iron. Therefore, speed control by flux is limited to wicking of the field. Because what we are saying here, if we are supposed to decrease the values of flux, this will depend on the saturation of iron. So it will be limited how we can control the speed by limiting the flux. That will be limited to the weakening of field, and this is the which will give us increase in speed. So we know speed is inversely proportional to the flux, and as we are decreasing the flux, we will get higher amount of speed of the DC motor. So this method is applicable over only to limited range, because if the field is weakened too much, we cannot decrease the fluxes. So this is the disadvantages of this method. फर्स्ट मेथड का डिसएडवांटेज क्या था? इन वेरिएशन ऑफ armature resistance, larger amount of power will get lost and we will get smaller amount of power because we were using their additional resistance. But here we will get higher amount of speed, we will get speed over the normal level. वहां पे नॉर्मल लेवल से ऊपर स्पीड नहीं मिल रहा था, बट हियर दिस थिंग्स आर डिपेंडिंग ऑन द weakening of the field. It means what? If our field winding is not that much good, we cannot reduce the flux, and that's why we cannot increase the speed. So there is a loss of stability in the speed control by using the variation of field flux. Now we can see about the variation of applied voltage. This is not complicated diagram. This is the same diagram. You can see here what I have done here. I am giving the power supply. Because what we are supposed to do? We are supposed to do variation in the applied voltage. It is nothing but supplied voltage. So here we are using DC generator as well as DC motor. Then we are taking the winding. So again, if you see, this is the motor generator winding and this is the DC drive motor winding. So what we are doing here, when we are giving the three-phase supply, at that time we are supposed to control the speed by controlling the applied voltage that we are giving to the armature winding. So this method is known as Ward-Leonard method. It was introduced in 1890. At the output of DC motor, we are connecting load. If you see here also with field winding, we are using the rheostat. तुम rheostat को एक तो resistor निकाल के उसमें slanting line arrow, or we can show again here one slipping line and one standing line, and you can give arrow to that slipping line. This is also a rheostat. This also as a rheostat. So here also we are using the rheostat with the field winding. We are connecting rheostat in series with the field winding because here we are supposed to increase the speed. So here we can see here in the DC shunt motor, if you see, M is the main DC motor. This is the DC motor and this is the DC generator. And what we are supposed to do? We are supposed to control the speed of DC motor. So G is separately excited motor, and we are calling this as a self-excited, separately excited, because you can see here we are giving the power supply to the DC generator. So the DC generator is driven by three-phase driving motor power supply, and which will generate supply voltage to that motor. The combination of the AC driving motor and the DC generator we are calling as a motor generator set, because here we are using DC motor as well as a DC generator. So we can say MG set means motor and generator set combined. The voltage of generator we can change by changing the generator field current, because you can see here when we are supposed to control the speed at that time, we are supposed to control the voltage because we are supposed to see here variation of applied voltage. So here, if we are supposed to control that voltage, we can control that voltage by controlling the field winding. And if you see here, we are connecting rheostat in series with field winding, so we can control that value of voltage. So here, the voltage of generator is changed by changing the generator field current, and this voltage is directly proportional to the armature DC motor. And as it will change, the speed of motor will also change. So the motor field winding is kept constant current, so motor flux will also remain constant, and we will get the control amount of speed at the DC motor. So here we can control the value of speed for the DC shunt motor by controlling the supplied voltage, and the generated field current is varied such that armature voltage changes and the speed will also change from 0 to the base speed. So the product of torque and speed we are calling as a power. Already we have seen that concept, because omega into T we are calling as a PM, mechanical power, and it is directly proportional to the speed. So here, if we are increasing the power, we will get increasing amount of speed. And how we are increasing the power? If you see here, since the speed control is carried with the rated current, because we are controlling the armature current with the constant motor field flux, constant torque is proportional to the armature current, and the field flux to the rated speed is obtained. That's why we will get here increase amount with increase in a power. There are some advantages of variation of applied voltage. We are calling this method as Ward-Leonard drive. It is it has inherent braking capacity, uniform acceleration is obtained, smooth speed control of DC shunt motor over a wide range. And if you see, it is having very large size, so its weight will also larger. This is the main disadvantage. Again, if you see, as we are having the larger size, there will be larger loss, higher loss, and it will be less efficient. And as we are having the larger size, its maintenance is also frequent, and we are using the larger weight, larger size, so its initial cost will also high. These are some disadvantages of the Watt Leonard, or we can say the DC shunt motor. And there are also some applications of the Watt Leonard driver. These are elevator, paper mills, mine hoists, diesel electric locomotives. All these are having smooth speed control of the DC motor over a wide range in both directions. Here we have finished about the speed control method. If anyone is facing any issue, you can ask me. Firstly, I will take your attendance. If anyone is facing any issue in any unit, you can ask the question. You all are supposed to join the Google Classroom. You will get there our video sessions, our PPTs, all notes, assignments, and you all are supposed to submit the assignment. Those who have not submitted, please submit the assignments. Okay. You guys can leave now. Thank you.